You're welcome to Ajay Sir YouTube channel for clarification of physics doubt and problems. And today we are going to discuss you about the concept of image formation by the lens. My dear friends, my dear students, I'm here to help you to understand the physics in better way. If you give time for physics classes, you'll have good understanding. Myself, Ajay Kumar Chaudhary. In case you want to join my classes, you are not able to get proper notification, you can WhatsApp 9838760378. That you can do. It will be very useful for you to be the part of this. What we are going to do just now, we are going to locate the image in a lens through ray diagram. Describe the image in terms of size, location from the lens, orientation and time. When it comes for telling the characteristics of image form, then we tell the characteristics as per these informations. So let us proceed further. Again, I want to remind you, share these videos to your friends so that they can also understand it. And next thing what you should do, subscribe this channel, share it and subscribe it. So image formation by convex lens. Convex lens is also known as converging lens. The reason behind it is that whenever the ray of light comes to convex lens, it concentrates. These are the rules which will follow it. Any incident ray traveling parallel to, it's a very important to understand. Any incident ray traveling parallel to the principal axis of a converging lens will refract through the lens and travel through the focal point on the opposite side of the lens. This is the first principle which we have to follow. If a ray is incident on the lens parallel to the principal axis, then it will refract through the lens and travel through the focal point on the opposite side of the lens. This is the first thing which is going to follow. Second rule which it will follow, that is any incident ray traveling through the focal point on the way to the lens, if it travels through the focal point of the way to the lens, will refract through the lens and travel parallel to the principal axis. These two principles will be observing it. If a ray is traveling through focus, then what will happen? It will become parallel to the principal axis. So, seeing these two, the image formation will take place. I hope these two concepts are clear to you. You see this object outside 2F. This is the first condition for the formation of image. We'll see it. So the first principle what we have studied. First principle we have studied that any ray which is traveling parallel to the principal axis. Remember it. Whenever you draw, this is your object. Let me change the color here. This is the object. Now the ray will travel parallel to the principal axis. See what we have understood. It will pass through focus. See, it is passing through focus like this. Second, we have studied a ray which travels through focus. This ray is traveling through focus. Will become parallel to the principal axis. See, it is parallel to the principal axis. And here, the point of intersection which you are seeing, this is images form. Now, image is This is, you see, whenever you have to describe the characteristics of image, you have to, first point you have to tell about position. Position means where it is formed. So you see, position is between f and 2f dash. So f dash and 2f dash. Second thing, you see whether it is smaller than object or bigger than object. So if you see here, the image form is smaller than object. Object is this. So it will be smaller. Next point, you see whether it is below the principal axis or above the principal axis. So the image form is below the principal axis, so it is inverted. Next, real or virtual. If the image can be formed on the screen, then it is real, and if the image cannot be formed on the screen, then it is virtual. So here it is real image. I hope students you all have understood it. We have kept the object beyond 2F, and then we have seen that a ray is coming parallel to the principal axis, meeting at between f dash and 2f dash, and these are the characteristics of image form. I hope you have understood it. We'll go for the next. In next diagram, this is the diagram you see. Here, the object is between 2f and f. We have brought object close to the, so this is our object here. Now the rays of light will take two rays parallel to the principal axis. This is one ray parallel to the, this ray is parallel to the principal axis. What will happen? This ray will pass through focus like this. Second ray, what you do? Second ray you take through the focus. It will become parallel to the principal axis. So this is the point of intersection you see, and at the point of intersection, there will be formation of image. This is your image. Now by observation, what you can tell about the image form? By observation, it is very much clear that first point you see, position is beyond 2f. You can say outside also. Outside 2f. Second thing you see, this image is bigger. Its size is bigger. Third, you see, it is inverted. Is it real? Yes, of course it is real. You have to understand, in case of convex lens, except one case, in all the cases, the image's form is real. I hope you are following it. You'll be able to understand it also. So don't worry about this. Now what we'll do, we'll go for another condition, another case. These conditions are very important for your examination point of view. Revise it thoroughly. Next case is object is at 2f. So when your object is at 2f, this is a very important case. Object is at 2f. So the main thing about when object is 2f, here is your object and here is your image. The image will also form at 2f. Object size and image size both will be same. And if we take the rays of light, let us take rays of light from here, one parallel to the principal axis. It will pass through focus. Another will take through focus. It will become parallel to the principal axis. What you are observing? Your observation in this case will be that the image and object both have same size. So position, first we come position is at 2f1. Second, size, same size. Third one, you see whether it is real or virtual, it is real. and it is inverted. So these are the characteristics of image form. Add to F1, same size, real and inverted. We'll go for the next condition of the image formation. I hope till now it is clear to you. Let us see the next condition. We are bringing object close to the convex lens. This is the condition. So in this condition, what we are doing, we are keeping object exactly at F. F means focus. When we keep the object at focus. So our object is kept at focus. We are kept here. This is our object. Now what will happen? We'll take two rays from here. One passing through optical center. Second ray take parallel to the principal axis. It will pass through focus. So these rays, they are not going to, they will be, here it is written no image form. But the true fact is that these rays meet at infinity. The ray, when object is kept, so they meet at infinity. And highly enlarged image form. And one more is that it will be real and inverted. This is the characteristics. So this point you should ignore. Ignore this point. This point need to be ignored. Let us proceed further. This condition is used of image formation for a particular case, and it's very important for us to understand it. When we keep the object between focus and lens, your object is here. Ray of light will incident on this, it will pass through focus. Second ray will go parallel to the principal axis. Now draw the backward of this. Since these rays are not meeting anywhere, here is the image. A dash B dash we can say. So this property is used in simple microscope. Simple microscope is simply a hand lens. If you want to hand the glass, you want to see the small organs, you can use this property. And characteristics you should see. This is very important for you to understand this property, that in this when you draw the diagram, you draw this dotted line, this line. This is your virtual image. The image will be virtual, erect and bigger in size. You can see magnified also. That's why this property is used as magnifying glass. Whenever you want that we should see enlarged image, we use this property of convex lens. This is one point which we should do first, but let us finish with this only. What we have done here, in this condition of this convex lens, our object is at infinity. The rays of light will come parallel to the principal axis. We have taken object as infinity. The rays are coming parallel to the principal axis. So when the rays will come parallel to the principal axis, what we have studied, they are going to meet, they will pass through focus.